The only limit to our realization of tomorrow is our doubts of today. Franklin D. Roosevelt. Welcome back to our sequel series. Today, drawing inspiration from Roosevelt's words, we are ready to face any uncertainties as we progress in mastering SQL. What's our goal for the day? To practice the numerical functions we covered in our last video. Whether you are just starting out or seeking a challenge, these SQL challenges are designed to sharpen your skills and prepare you for those tricky technical interviews. Before we jump right in, a quick recap. Numeric functions in SQL are used to perform operations on numeric data types. Some commonly used scalar numeric functions include ABS or absolute function, ceil, floor, round, trunc, sine, power, square root, and mod functions. Now let's begin with the queries of simple complexity. For your practice, import the dataset into PostgreSQL from Kaggle. If you are following the playlist, you must have already done it. If not, please check the video link placed in the description box. Let's begin with a simple query. Round the weekly sales to the nearest integer from the table Walmart sales. In real time, we usually do this for reporting purposes. Let's write the SQL query for this. Open PostgreSQL, place your query. Before we start writing the SQL query, let's see what is present in the table Walmart sales, which is the Kaggle dataset that we have imported. Store level weekly sales are present in this table. If you see, there are different store IDs. For each store IDs, on a daily basis, weekly sales published on each week. This is the date of the week the sales are stored. And there is a Boolean value called holiday flag 0 or 1, temperature, fuel price, and some other values called CPI and unemployment. CPI is nothing but consumer price index. So this is the data set representing Walmart's weekly sales. All right. Query is direct. Round the weekly sales, right? Select use the round function of weekly sales. The column is present straight in the table. So round of weekly sales from Walmart sales. Just so we can see the difference, let's have the original column value and then rounded value. Give the alias as rounded sales, original weekly sales. Let's execute. Here you go. The first column represents the weekly sales, which is the original value present in the table. And this is the rounded value where the round function is applied on top of this original value. So if you notice here, after decimal point, if it is greater than or equal to 5, then the rounded value will be the immediate maximum number. 7.44, this is less than 5, so it remains as is. There is no increment to the value prior to the decimal point. Wherever you have less than or equal to 5 after the decimal point. Let's take one more example. After the decimal point, you are seeing 9. So the expected value is immediate incremental value. So this 29 will become 30. So that's the round function is about. All right, heads down. I bet you'll knock out the easy challenge. Let's tackle the medium complex ones. Identify the stores where the temperature was recorded as a negative value and find the positive equivalent of these temperatures. Again, it's from the same Walmart sales table that we imported from Kaggle. Place your question on the PostgreSQL. Let's look at our focused columns. Our focused column now is temperature. Our ask is to get the temperature wherever it was recorded as negative and find the positive equivalents. First, let's identify if the temperatures are negative anywhere in the table. How do you get that? To get your negative temperatures, simply use where condition. To get your negative numbers, anytime it's less than 0. As simple as that. Let's get temperature. Only one value with negative temperature. All we need to do is convert this into its positive equivalent. What's the function to convert? Absolute. ABS of temperature. You got your negative value and its positive equivalent as well. That's your absolute function. In Walmart sales table, round the fuel price up to the nearest integer to estimate the maximum possible cost. Question on the tool editor. Let's take a quick look at the table. This time, fuel price is our focused column. If you closely notice the question, it is asking the maximum cost of each sale record by rounding the fuel price. Since it is giving a clue of using a round function, do you think using a round function will get us the maximum possible cost? Let's check. Select fuel price, round function as rounded price from Walmart sales. Execute it. Typo. 2.5. Yes, maximum possible cost by rounding the fuel price up. This is almost correct, but fails in some of the cases. Look at 3.01. Is this the maximum possible cost or less by 0.01? It's less, right? It is not maximum possible cost. This is failed because we used round function. So the ideal function to use whenever we are asked to get maximum of the existing value, you should always go for ceil function, not round. Round function rounds the value by the logic of greater than or equal to 5. But the ask here is maximum possible cost. Let's use ceil. You can directly put it here so you can clearly see the difference. Ceil of fuel price, alias as max price. Execute it. See, this is our maximum price, even if the value after the decimal is less than 5. For the fuel price 3.29, round function gives 3 while ceil function 4. We want the max price. So the function to be used here is ceil function. So we got the difference through one query. So we clearly noticed the difference through this SQL challenge. You're ready to move to the complex category. Calculate the power of weekly sales raised to 3 and filter for sales greater than a million. Open PostgreSQL. Quick look at our table data. The column we are going to use in this question is weekly sales. In a way, the ask is direct. It is asking us to use the power function. Power of weekly sales by 3 times. Alias name as powered sales. Let's give original value here from Walmart sales. Execute it. So this is the value. We missed a clause. It is not only the ask is to raise it to power 3, but for the sales greater than this number. So what should we incorporate in this query? It's a simple where clause, where weekly sales is greater than let's see if we have any number or not. Yes, all the numbers are almost the same. Let's change this number and see if there will be any difference in the result. You don't have anything here, that's why. So this is the result that you see here. Wherever the weekly sales is in the limit of this 20 lakhs, raise it to 3 times. That's the number we are seeing here. This is about power function. Next one. Determine which store records have weekly sales such that when raised to the power of 3, the result is greater than a million. Open PostgreSQL and place your question. Let's check the data in the Walmart sales. This is your table data. The question here asks for the store records which have weekly sales when raised to power of 3 should be greater than 1 million. We can have all the columns in our select clause, but the focused column on which the numeric function to be applied is weekly sales column. Let's start the query. Let's pick the store column and then weekly sales column. Now, what do we actually want? Raise to the power of 3. Let's use the power function to 3 times. Give it an alias name as raised sales. We want to compare it with the original weekly sales value. So let's have the weekly sales column next to raised sales. All right. From the table name, is this enough? No. The query demands another condition, that is the result is greater than 1 million. This can give you the raised sales, but we want only the sales which are greater than 1 million. That means it is asking to add a filter condition where is it weekly sales greater than 1 million or power of weekly sales, comma 3 greater than 1 million. Which one is correct? It is power of weekly sales greater than 1 million is the correct one. The reason is the result. So we are putting the power function. This will provide you the result which is greater than 1 million. Execute it. So this is your result. Basically, you are seeing all the records in your result as every value falls into the category of greater than 1 million filter. That's how you write it. So this is the query using power function. And that concludes our exploration of numeric functions for today. Remember, consistent practice is key to mastering these techniques. So, dive into some real world datasets and experiment with these functions on your own. You'll be amazed at the power you unlock for data analysis. Happy practicing!